Hey, what's going on, students? Let's do the Aquarium, Esssquarium. What do we got going on here? It says, a new board game has preset angle measurements for a 4-section spinner. Okay, so like one of these dudes, right? You ever seen a board game with a spinner? And then it points, and we have sections A, B, C, and D, it says, it looks like. Yep. The chart below gives the degree measurements for the section. Oh, for the sections A, B, C, and D. Okay, so, all right, so that means section A is 120 degrees. Cool. Section B is 90. All right, neat. You don't need to draw this picture, by the way, so if you're drawing this, you don't need to. Section C is 100 and section D is 50. So they're obviously not all the same. They're different sizes. It says if 2,000 spins were to be simulated, find the expected totals for each section. Hint, a full circle is 360 degrees. Oh, basically what's going on here, students, is they're giving you the degrees. The degrees in terms of a full circle is like the slice. So you're getting 120 degrees of the 360. You're getting 90 of the 360. You're getting 100 of the 360. You're getting 50 of the 360. So one thing you could do is you can change these into decimals and then take the decimals times 2,000, or you can just straight up use these or even reduce them. So like 120 out of 360 is actually a third. So you could take 1/3 times 2,000, okay? If section A is assigned 120 degrees out of 360, then it should get 1/3 of the spins, okay? 90 out of 360 is a quarter, which is 0.25. So you could take 0.25 times 2,000. Okay, oops, need another one. 100 out of 360, you could write that as 100 over 360. Okay, obviously that could reduce to 10 over 360, or you could keep reducing as small as you want it. I don't think this is a very nice decimal, so this would be a situation where I would not recommend changing it as a decimal. I mean, all of these, you can literally just go like this, times 2,000, and then same thing, times 2,000. You can do all of that over and over and over again. But 50 out of 360, again, you could reduce that. You can do 5 out of 36. Actually, I'm going to go ahead and do that. 50 out of 360, the zeros would cancel, so you can do 5 out of 36. However you want to do this, that all works, whether you do a reduced fraction, a decimal, or just the actual whole fraction, pre-reduced. So there you go. There's whatever you want to do, whatever makes you comfortable. The problem is some of them are not going to land on a whole spin, so make sure you round to the nearest whole spin. So there's no decimal spins, okay? So here we go. So 2,000 to the 1/3 power. Oops, not 1/3 power. 1/3 times 2,000, or 2,000 divided by 3 is the same thing. You get 66, 6, and then 6 repeating. Okay, so to the nearest spin, that would be 667 spins. Okay, it should land that many times. Is it going to? Probably not, but that's what's expected. 2,000 divided by 4 or times 1/4 should be 500. You should get B 500 times. C 10 over 36 times 2,000 is 555.5 repeating, so that would be 556. And then 5 out of 36, 5 out of 36 times 2,000 is, oops, times 2,000, I forgot it right there, is 277.7 repeating, so that'd be 278. All right, so again, round all of these to the nearest whole spin. If you get a nice one, good job. If you get one that's not so nice, make sure you round to the nearest. In all of these cases, we would round up, and I think that's about it. So use a fraction, use a decimal, but take the degrees over 360 to get the slice of the pie, literally the slice of the pie, and then take that times the total spins, and you'll get your expected totals. All right, that's about it. See you in class.